Now we're going to go through the examples relating to section 6.3, 3D objects, and we're going to be calculating the volume and surface area and all that of 3D objects. In the last video I explained the tolerance, degree of accuracy, percentage error, so now we're just going to do examples relating to that. So find the volume of this truncated cone correct to one decimal place. Usually when you get this situation, you have to get the larger volume and take it away from the smaller volume, and then you'd be left with your truncated cone. This radius is 6 and this radius is 4. We unfortunately don't know the height of this one, and we know the height to the lower part down here is 8. So whatever this height to the left is, call it h, this is going to have a height of h minus 8. So that means we have two right angle triangles because of this situation that we talked about earlier. A right angle triangle there. And if we look at that now more closely, we have two triangles. I'll just redraw them. So we have h, right angle, and 6, and we have h minus 8 and 4. So if we found h, we'd know this one as well. Then if we use the ratio of similar triangles, this is a concept you'll learn more about in geometry, but for this question, if in similar triangles, if this is A and this is B, they are similar to each other because they might have the same angles and there's just a scale factor between them. So if we call this C and this D, what you could say is A over C is the same ratio as B over D. Or you could do it the other way around. C over A is the same ratio of D over B. And we're going to use that idea to help us find h. And if we find h, then we would be able to get the volume of the cone. Volume of your larger cone, because your formula is equal to 1/3 pi r squared h. So we need to know the height. So we're going to find the height, and we have our two triangles in blue. So here we have h all over h minus 8 is equal to 6 over 4. And now doing some algebra with that, we could cross multiply, or we could multiply both sides by 4, and that gives me 4h over h minus 8 equals 6. And then when we multiply both sides by h minus 8, we get 4h is equal to 6, h minus 8. So we get, I just need a little bit more room down here. So that implies 4h is equal to 6h minus 48. So 2h is equal to 24. So h must be, sorry, it's not 24. 2h is equal to 48. So h must be 24. So h is equal to 24. So if we know h is equal to 24, h minus 8, well 24 minus 8 must be 16. So I'm going to draw that up here. H is equal to 24 and H minus 8 is 16. So if we use that now to get the volume of the larger cone, this one got moved. Now, volume of your larger cone. So the radius of the larger cone is 6. So we get 1/3 pi 6 squared by 24. And we can put that into the calculator and you get 288 pi. And the unit is centimetres cubed. Now we can calculate the volume of the smaller cone. So 1/3 pi r squared h. For this now, r is equal to 4. So we have 4 squared and h is going to be 16. And in the calculator that gives us 256 all over 3 pi centimetres cubed. And now you can get the volume of your truncated cone. That's going to be 1, take away the larger one, take away the smaller one. So 288 pi minus 256 over 3 pi gives me 608 over 3 pi. So that's your exact answer. And then the question said to 1 decimal place. So 636.7 centimetres cubed. That's our final answer. I am just going to show you method 2. This formula is in your log tables and it's a lot more straightforward. This is your smaller radius, your larger radius. So in our case that was 4, that's 6, and the height's 8. You can sub those into the formula here for volume. We don't need this length, that's only for the area one. And you get the same answer. Both methods are acceptable, except I did want to emphasize similar triangles in this question and the scale factor. So next we'll look at example 2. So Matt weighed 85 kg before training and 81 kg after. He took both measurements on a scales in kg, and we want to find the minimum and maximum values for his weight loss. So this is a scale, and in my last video I mentioned that tolerance when it's measured against a scale is always plus or minus 0.5 of the unit. So tolerance so we're plus or minus 0.5 kg there because his scale is in kg. So therefore we want to find the max or the min before. So we'll do before max, the before min or minimum. We'll calculate those. So he could have either been 85 plus 0.5 gives me 85.5 kg, or he could have been 85 take away 0.5, he could have been 84.5 kg. And we'll do the same for after max or after min. Well, using the same idea, 81 add on 0.5, we get 81.5 kg, and taking out away 0.5 taken away from 81 would give us 80.5 kg. And now we have to think the maximum weight loss would be using this measurement. The maximum weight loss would be that measurement taking away this measurement. It gives us the biggest difference. And then the minimum weight loss would be this one, take away this one. So I'm just going to write that down. Max weight loss was 85.5 because that was the biggest weight that he could have initially been, and minus the lightest weight that he could have been after, and gives us 5 kg. So he could have lost a maximum of 5 kg or a minimum. We'll do it quickly. So we have 84.5, take away 81.5, he could have lost 3 kg. So then our tolerance interval is, if we look at these two values, 5 and 3, there's a difference too between them. So what you could have said then was, well, the tolerance, we could say his weight loss, we'll say it was 4 kg, and we could have added or taken away 1. I know the question doesn't actually ask for tolerance interval, but it is important to note. Tolerance interval for weight loss, we'll say that was 4 kg plus or minus 1 kg from our calculations. And that's that question finished. Now if we look at our next example, I apologise. So a company makes ball bearings, which are spheres. Some questions you'll notice talks about ball bearings, and it might not tell you that they're spheres. So now you know a ball bearing is a sphere. So, and the ball bearing machine makes them with a diameter of 12 millimeters. They claim they're produced to an accuracy of within 0.02 millimeters. Find the largest and smallest ball bearing volumes produced, and then find the percentage error of the diameter and the volume. So the first little bit of calculation is done there for us. If this is the diameter, the maximum diameter is 12.02, the minimum diameter is 11.98. So if we calculate in here, they've said find the largest and the smallest ball bearing volumes produced. So we're going to do that first, and then we're going to worry about part I and part II. So it's a sphere. So the formula for the volume of a sphere is equal to 4 over 3 pi r squared, r cubed. And if we want our maximum volume max, we have 5 over 3 pi, or half of the diameter, and half of the diameter is 6.01 cubed. And when we put that into our calculators, we get 909.31 millimeters cubed. And now if we calculate the volume minimum, is going to be 4 over 3 pi r cubed, and if we have this diameter we get 5.99, and calculating that gives us 900.262 millimeters cubed. It's important you get your unit right, otherwise you lose a mark. And we'll also need, if we're going to be getting the percentage error, you're going to need the actual volume. So then we could get actual volume. So that's going to be 4 over 3 pi. Actual volume is when the radius is 6. And cube that, and we get 904.779 millimeters cubed. And now if we just get the percentage error, so the percentage error, I mentioned this in the last video, the percentage error is the error, so the difference in the two values, all over the actual value, and then write it as a percentage. So multiply it by 100 or 100 over 1, whichever you prefer. So for the diameter, percentage error of the diameter, that is going to give me, the error is the difference in the two values. So we have to take one away from the other. Actually, the difference between your maximum and your minimum is just going to be 0.02. So that is what you put on the top of your fraction, 0.02. The actual value is 12 over 12, and write it as a percentage. So we'll multiply it by 100, and that gives us 1.666 reoccurring. So I'll just write 7%. And then the percentage error of the volume, the error is going to be one take away the other, so we have to do 909.31 take away 904.779 all over the actual volume, and the actual volume is 904.779. Multiply this by 100 and we get 0.5%. So that's the end of our examples relating to this section. I hope you enjoyed, and we'll give the questions a go. Thanks for